Good morning, everyone. There's, I'm sure there's probably a few more people to join yet, but we need to get going, of course. So time's moving on. So as I mentioned before, welcome to another webinar. As you can see, it's being December. It's a Christmas special I'm doing for you here today. So it's going to be a lot about futures, as the title states on there. Before I get started, I will just throw a few caveats in there for you. Obviously, as this mentions, this is futures. Okay, so please don't expect to be buying this today, tomorrow, next month, or maybe some of it, maybe not even next year. There is, as I say, this is a lot about futures, and it's about the technologies as well. It's explaining what they are. Not necessarily completely how they work. It's not going into real technical detail, but it's just explaining some of the details around some of the new technologies. Of course, it's all stuff that TP-Link will be doing, otherwise I wouldn't be talking about it. Yeah, it's not necessarily for you to buy today. So please be aware of that. Don't expect this to be appearing in a short period at all. Okay, so let's get on with it and let's explain some of the things I'm going to be talking about today. So these are the topics. Some of it does exist today in TP-Link products, and I'll point those out. And it's actually mainly, if you look at the HomeShield stuff, it's certainly becoming available now, but also right down the bottom there, the AI and machine learning stuff. So we'll cover off where we deploy that, what we use it in, and how some of that works for you. But then there's a lot of information in between, a lot of different subjects and topics there that we'll get through today. It's got, like I say, it's a very, very top level overview, because otherwise, if we went into each of these topics, as you can imagine, we'll be here for hours. It is only a few slides on most of these topics, a few more slides on some, but it's just covering off what there is, what we're doing, where we're going, sort of things that are happening. So I hope you find it interesting, and there will of course be a Q&A at the end of it. So we'll take a step in. First of all, looking at HomeShield. So HomeShield is our new security and antivirus and protection application, which is already deploys in the TP-Link Deco range, which is the retail product, as I'm sure you're all aware. But of course, we're here from an Aginet side, which is the ISP product portfolio, and the HomeShield solution is being deployed into the Aginet products step by step. So for those who don't know what it is, we'll just go through some of the features, some of the abilities, some of the functions, some of the things you can do with it, and what. So looking at this to start with, as I say, very, very top level. It provides you the ability to block content, to set time limits for kids. So there's parental control elements in there. There's antivirus stuff in there. There's VPN in there. There's a number of different things in there. So let's take a bit of a deeper look. The HomeShield application as well is two sides to it. There's a free part of it, which you will get as part of the product, which are these bits that we're actually seeing on the side. Just over here, these two elements here, just giving you a quick view. There's a table coming on the next slide, which will give you a bit more detail. But you can see that there's various different things that you can do for free, or you can then pay for the subscription side on and do an upgrade where you're offered more facilities, more things you can do, more control, etc. So just looking at those, let's see how they actually set up. So HomeShield itself is kind of broken into these four elements, mainly these two here, but the other two down the bottom. So network security, basic, advanced, and device antivirus sections, and you can see the various different things that in the basic, this is what you get for free, and it kind of covers the application scenario of in the home stuff. Same, a few more things that you can actually do there, subscription, but it covers for the home. But then antivirus, obviously in the home, but also does what we call on the go as well. I'll explain that a little bit more in a moment. And then on the parental controls, you can see the various things. Obviously, this slide deck will be shared out to you also. I'm not going to sit here and read all the different things for you. You can refer back to this when we share the deck. But you can see it's pretty comprehensive, and one part of it being called HomeShield app, and that provides a very, very good solution for the parental control element. Goes much further than what traditional parental controls do at this moment in time. So we just have a look at those a little bit further. On the devices antivirus, oh, that's a mouthful. You know, there's a lot of stuff that's actually built within that one element. It's not just about the antivirus side, as you can see here. Also brings in, you know, the online threat and the firewall, but also, you know, VPN client and privacy monitoring as well. So it brings on a lot of features and function that you can do from within the HomeShield antivirus section. On the parental controls, so the kids element, there's a lot of functionality in here with, you know, your web filtering, obviously, you know, for blocking certain websites and content from the website of things. You can set up profiles for your different age children. So, you know, it may be that some of your older kids, you may want to allow to see certain things. It may be to do with homework stuff and things like that. You know, there's various different reasons why you might have younger ones being blocked for some of the scary stuff and things like that, which are older ones you might want to allow. Restrictions in YouTube and other streaming elements, you know, to make sure that they're not able to access some nasty content, we'll call it that at the moment, shall we? And also app blocking as well. So certain apps you can actually restrict from being used or downloaded or installed or anything like that, or even restrict times and things like that on certain applications. If it was a gaming one or something like that, you might want to allow your kids to be able to use it, but you might want to restrict them on the amount of time they can use it for. And then, of course, there's the regular safe search element, which is kind of a little bit more over and above the web filtering, because it now starts to really focus in on particular subject matter. So it's a very comprehensive parental control element for the kids there. And so when we're talking about HomeShield, I mentioned about this additional element here. Now this brings on a few extra facilities, a few extra functions and features. Being able to control their phone, for example. What I mean by control is actually stop them installing things if you don't want them to install apps or use apps, or even the opposite way round, of course, is if you've installed an app onto their phone which you require them to have for whatever reason, you can stop them uninstalling it if they were wanting to do that. But also disable in-app purchases, those sort of things, obviously, which cost a lot of money. So a lot of good control elements there. You can allow certain amounts of screen time, set the times and the duration, how long they can have, and also even totally lock out the device so that they can't do anything. So the device is disabled pretty much. But the real good bit, in my view, and you'll see as we go through this deck, a lot of this is opinion based. Because it is new technology stuff, but my feelings, I think this is a great one, certainly for, you know, kids in today, going out, being able to track them, understand where they are, and know they're safe and obviously contactable. So a very useful element. So that's kind of on the go. Now, when we say on the go, what we're meaning by that is it doesn't just have to be within the home. All these features work when they're outside them. Obviously, the tracking would be a bit pointless just having it working at home, but everything here works when the children are out and about, wherever they are. They don't have to be on your Wi-Fi at home. and you still have that control over the device. Another element of the HomeShield is actually reports. So it's all well and good maybe blocking kids from using certain things, or setting up certain firewall controls, things like that. But of course, there's always new things coming along, and maybe that you're not aware of at the time, but the kids, they tend to be, and they'll get onto them and they'll start looking at them. So these reports are quite important, because they'll be able to show to you what your kid's actually going on to, where they're using things, what they're viewing, what they're browsing, what they're playing and gaming and things like that. And so these reports will actually help educate you, or the parent, into a position of being able to potentially restrict them if that was required, or allow things. So quite an important element of the HomeShield is the reporting, to understand that you're actually blocking and running and restricting or allowing the correct things at the right times and things like that. So a very useful piece of information from the reports as well. And then just finally on HomeShield, the products that is going to be enabled in, please note, like I said, will be enabled in. So that means they're not necessarily there today. Some of the products have it today, but some of them don't. And you'll notice that pretty much everything here is all Wi-Fi 7. So if you're looking at Wi-Fi 7 devices in the Aginet range, then they're going to have HomeShield on them at some point. The one exception here is the EX820V, a very successful product for us on the Wi-Fi 6 portfolio, a great product. You can have it on there, but it is a project-based request, and so there is an MOQ that goes along with that to have HomeShield added into a particular project for you. Okay, so that's HomeShield, and we'll move on to Matter. Not sure how many people are aware of Matter, or what it is, or how it works, or what it's all about, but let's see if we can kind of cover into that. So what is Matter? Well, Matter is a protocol, a language, an overarching technology, a communications messaging structure that is being put together to enable all devices in the IoT world from various different suppliers or ecosystems or vendors of these products to all work together. Now, of course, Matter is not the first to have come out with this intent. There was things like Thread and others as well that were hopefully meant to achieve this, to enable all ecosystems in the smart home and IoT world to communicate with each other. But yes, some of those fell by the wayside, and it didn't work. And so Matter has come about, and I'll explain what's different about Matter shortly. But essentially what it does, at this moment in time, or before Matter, as it's saying on there, you've got all these various different ecosystems, whether it be Apple or Google or Amazon or TP-Link Tapo, all working in distinct, separated ecosystems. And yes, you could, of course, get them to work by doing skills and doing all sorts of bits and pieces, but pretty challenging for the home user. It's all right for somebody who's relatively tech savvy, but most home users would need support and help to be able to do this. So what Matter does is it actually sets up a communication language which enables all ecosystems to all talk together. And so they can all come under one hub, one ecosystem, actually controlling all the different vendors and manufacturers' devices. Okay, so obviously that simplifies the whole setup and operation of a smart home for a user, especially, as I say, if they're non-techie. And trying to set up the if this then that routines, where if you open the door, the light turns on, the camera takes a snapshot, or all those sort of things become much easier. So why is Matter actually the technology that seems to be going to take over? As I said, there's been a few attempts from other technologies before in the past. So why is Matter going to be successful? Well, actually, what it really comes down to is pretty obvious, I suppose, but the reason is the likes of Amazon, Apple, Samsung, Google, and TP-Link and many others have all adopted the Matter technology. Now, this is the first time that that's actually happened with any of the technologies. Yes, you used to get a couple of them buying into it, like into Thread. I think Google and I think Samsung it was as well also kind of bought into it, but Apple didn't, not really, and neither did Amazon. So you could never really have that full control, that full ecosystem coverage with all the different setups. Matter has absolutely provided that, and that is why, again, back to my opinion, is I believe Matter is absolutely going to be the technology that ensures that all ecosystems can work together moving forward and into the future. So Matter as a technology, surprisingly, it's probably been around for about 5-6 years, but it's taken time to actually get all these ecosystems working together. There's the Matter Association or organisation, which has a lot of associated members, of which we're part of that as TP-Link, as Apple and Google and Amazon and Samsung and many others, all putting in their communication requirements, their little bits of script to be added into the Matter complete portfolio of communication protocol to grow and to ensure that everything works together. So of course that's taken some time, but that is happening more and more, and there's still a long way to go. Don't get me wrong, this is not a finalized, finished solution. There is a lot more to go and a lot more devices to add. And in fact, as you can see on here, the latest Matter version, version 1.5.0, that now includes the ability to bring cameras into the Matter ecosystem as well, which of course is a big one for TP-Link. As you know, we do a lot of cameras in the TAPO environment, and we've been working on that as part of the protocols and everything to submit into the Matter organization to bring this all together, and that has now been released, and so we can now start to port Matter into cameras as well. Now, when I'm talking about this, what we're actually doing is in the protocols or in the communications is actually doing a Matter equivalent of the same thing that we do in the standard ecosystem. For example, view camera, set motion detection, take a snapshot. It's all those sort of things, and it's the command sets but converted into a Matter command set, which means that any other organization, any other ecosystem that wants to control a camera, if they use the Matter command set, it will control, for example, a TAPO camera that has Matter, because Matter is absolutely a complete standard, and anybody who wants to add a device into the Matter ecosystem must employ the Matter command set for that type of product. That's what enables everybody to work together, and that's why it's become successful. Another element is the QR code. What Matter have dictated as well is said, okay, it's one thing having the communications, but setting up needs to be made simple as well. And so for each device type, whether it be a camera or a sensor, a bulb or whatever it may be, the QR code is absolutely common across each of those device types, which means when a end user comes to install anything or set anything up, a common QR code is used across the ecosystem of Matter, which enables it all to be set up together. Okay. So for now, where are we? What in TP-Link TAPO world? The device types that we have that are Matter capable already. It's obviously our hubs and controllers and things like that, and smart plugs and bulbs. And don't get it's only not only just one bulb or one smart plug. There's also the power strip where you've got the 4 power strips, and we've got a Matter version. All the various different types of bulbs. There's Matter devices and things there. Different Matter elements of bulbs. But also having the hubs and controllers, that also means that all of our sensor range down here, which are not matter themselves, but because they communicate into a hub, then that enables them to be going onto the Matter ecosystem through the Matter bridge or the Matter hub or the Matter controller. As you know, we do robot vacuum cleaners. We've even got Matter vacuum cleaners now, so that'll be coming along very shortly. And as I was mentioning earlier, the cameras. So I appreciate I've got the picture of one particular camera here, but there will be a set of cameras. Not all devices, not all cameras, not everything will be Matter, but there will be Matter versions that will definitely provide the various different classes of product type that will be included into the Matter ecosystem. Okay, so that's Matter. Wi-Fi 8. Well, here's one for you. We only just started doing Wi-Fi 7, right? I'm sure a lot of you have seen about Wi-Fi 8 on the media, social media platforms out there, and lots of discussion in the PR areas about Wi-Fi 8 and everything like this about what's coming next. So let's just give you a first view from a TP-Link perspective. We have already shown our Wi-Fi 8 solution. We have already prototyped, we've already done the testing, it's being shown, and we announced it at Network X this year in October. A few other people did the same. Everybody's got their own variation of what Wi-Fi 8 is at the moment, because it is not a fully ratified and authorized and signed off by the Wi-Fi Alliance solution yet. That is still to come. So there are obviously a lot of features and functions that are being stated, Dana, as being included in Wi-Fi 8. So let's start to have a look at some of those. I'm just kind of calling out some that I think, again, opinion. Don't forget we're talking futures, and a lot of this down to opinion. So some of the important ones that I think are coming in Wi-Fi 8. Yes, Wi-Fi 8. I've got a table on the next slide which shows all of the features that people are talking about. But for now, I just want to focus on some of these because I think these are the important ones. The improvement in reliability. Okay. And that comes from the improvement in latency or less or lower latency. That enables the stability, the greater throughput, which improves the range, and so again improves the reliability and the stability at a greater range. So that's quite an important one. Multi-AP coordination. So this, very important when you're talking about a mesh environment where you've got multiple APs, and with Wi-Fi 8, there's a lot more communication between the APs and a lot of more, I guess you'd call it negotiation in a user or a client being passed around over the mesh environment. So there's a lot more control there. So again, that all adds to the stability and the reliability. But I think one of the major ones is the low power. So, all of you have seen as we've gone through, Wi-Fi 5 to Wi-Fi 6 to Wi-Fi 7, I'm sure you've seen and maybe even felt the devices get hotter and hotter, and as you go, as you're doing more processing and more stuff going on, using more power generates more heat. When you generate more heat, you have to dissipate that heat in one way, shape, or form, which has tended, as we all have seen, to mean bigger and bigger products to be able to enable the heat dissipation. So the lower power is kind of like has a couple of additional advantages. Yes, there's the eco element, the green element, where using less power has to be a good thing, and certainly in people's homes where they can be using less power to run devices of this type, their routers and mesh devices, makes it cheaper to run as well. And obviously the eco element of that. So the low power certainly helps there. But one thing that, again, opinion, I'm assuming, and it makes sense, and it kind of, there's a few comments about this, the lower power meaning less heat from the power, means the potential to build those slightly smaller or maybe even significantly smaller devices moving forwards. So hopefully we'll start to see smaller devices again. We got to a point of, a number of years ago where Wi-Fi was actually in quite a small device, but it's had to get bigger because of the power and therefore the heat. Maybe we're going to start to turn the corner, go back the other way a little bit here. So there's a full list of everything that is meant to be the difference between Wi-Fi 7 and Wi-Fi 8. I've highlighted a few there in yellow, which again, there's kind of repeating what we were talking about just now. But, with some additional advantages, enhanced AI, that's all obviously locked into that mesh networking and that multi-AP control stuff, which I was mentioning on the previous slide. But you'll see there's actually some that is, pretty similar, from Wi-Fi 7 to Wi-Fi 8, even in the channel bandwidth and modulation. Now, okay, it says under investigation here, but we are also restricted by legislation on what bandwidth we can use and the frequencies we can use and all those sort of things. So there's going to be a lot that remains the same. Okay, so a lot of stuff being done, various different people coming out with extra things. MediaTek are looking at a smart MLO environment. So it'll be interesting to see where they're going with that, where they improve the spatial efficiency, as it says. But there's a number of other bits and pieces down here where, yes, extra features. What will that really mean? That's where it brings all the stability and maybe a potential speed, or perceived speed over a range. So we'll see. Again, this is just a very, very high level view of where we are with this. The important bit to get across is the timeline. I've already mentioned it, a couple of times here. Wi-Fi 8 is targeted for 2028. So please don't start selling Wi-Fi 7 and start promoting Wi-Fi 8 to customers just yet. And that's part of the reason for me talking about this as a future today, is because what tends to happen, some of these Wi-Fi technologies get talked about in the press and the chipset guys get out there and start promoting it. And yes, it's all going to come, and it is going to come, and everybody starts focusing on it. Don't focus on Wi-Fi 8 yet. Sell Wi-Fi 7. Wi-Fi 6 is still being sold, but sell Wi-Fi 7. That's what's out there today. It's going to be around for a number of years. When I say target for 2028, yes, we will have prototype product. We'll have first release product before then. You will see them come about, as you will from other vendors, I'm sure. However, the ratification by the Wi-Fi Alliance of Wi-Fi 8 is not until 2028. Then products are going to have to get into the mainstream and things like that. So, like I say, don't stop selling Wi-Fi 7 thinking you're going to be selling Wi-Fi 8 tomorrow, because you're not. It's not happening that quick. There's a lot of work to be done on it. It will come along, but it's a few years away yet. So don't start thinking Wi-Fi 8 tomorrow. Okay, that leads us nicely on to Wi-Fi sensing. So, Wi-Fi sensing. What is it? How does it work? What does it do? Some of you may have seen some bits already. I just wanted to cover off, Wi-Fi sensing from a TP-Link perspective, but also, to a certain degree, again, some opinion-based, my opinion, what it can be used for, but also a bit of history on it. Because what I will say is one of the things with Wi-Fi sensing, it's not new. It's been around. And I wouldn't just say it's been around for years, it's been around for decades. Because Wi-Fi sensing, their ability to notice a object interfering with RF signals, has been around since before World War II. So, radar, there you go, that's an exact same thing. Okay, the difference is now, of course, is we're actually pulling it into a home environment and it's becoming mainstream and it's something we can actually start to use at home. So it's not new, the technology is not new, okay, but how we're using it and what we're using it for and where we're using it, that is new. So the way it actually works, I'll go into a little bit of techie stuff here just to explain it. So the main element is what they call the CSI, the channel state information. Now, that is the part of the Wi-Fi chip that we actually interrogate and we get information from to be able to understand movement, motion, objects, all those things within a Wi-Fi environment. And the graphic actually explains it very well. You know, if you look at this, if you imagine all those white wavy lines, that's your Wi-Fi, that's your RF signals, that's all your Wi-Fi waves going around the home, around the office, or wherever it may be. And as you walk through those, as you move through that, or motion goes through that, you disturb them. You change their shape, you change their refraction, the reflection, how much they're absorbed, how much they're scattered, how much they're affected. And that is picked up within the Wi-Fi chip by this element here, the channel state information. Clever stuff then comes from there is you are then how you interpret that, how you read that channel state information, and how you then use AI in the back end to start understanding what it really means. Okay, so someone or something moving through the RF, through the Wi-Fi field, through changing those waves can be detected as motion, can be detected as positioning once the AI gets that sophisticated, can also detect size, shape. So is it human? Is it pet? Is it a dog or a cat? But actually, it can be really, really sensitive to the point where not only can you detect if it's human or not, you could actually start to detect individuals. So you'd know if it was, one person who's, I don't know, 5'6" and another person who's 6'4". You can start to detect the differences like that. So it's really clever, really gives and opens up a whole lot more opportunity. So some of the other advantages, and to me, the big, and again, opinion based, but to me, the big advantage over Wi-Fi sensing when you're comparing it against traditional, motion detection with IR or something like that, is Wi-Fi covers the whole environment. We'll call it that because it may not be the home, maybe an office, wherever it may be. And what I mean by that is it goes through walls, it goes around objects. If you think about using your Wi-Fi on your mobile, wherever you're sitting in your home, if you've got a signal there, that's coming through walls, it's getting to you. Yeah. And so that means Wi-Fi sensing also has the same ability. So unlike a traditional motion detection using IR or that sort of thing, which is blocked by walls or blocked by furniture or blocked by objects in the way and can stop motion being detected, with Wi-Fi sensing, that gets around that. Even to outside, of course, you'll know very well yourselves that your Wi-Fi, you might be outside in the garden, right by your front door or something like that. And front door is a pertinent comment I make there, because you've now got the opportunity to detect somebody coming up to your front door outside. And as AI gets more sophisticated and the algorithms get more sophisticated, we'll be able to start detecting, is this someone who should be coming to your front door? Is this one of your family members? Is this, your brother, your mother, your dad, or whatever, somebody, a friend who comes to your door regularly, and start to learn that against someone who you've never seen before coming to your door, who could be an intruder, depending on the time of day they're coming to the door. So it starts to really open up some very sophisticated sensing, security and control environment and parameters. So just looking at some of the other use cases, now some of these are absolutely there today. All of these are absolutely possible, but some of these are going to need some, as I was referred to earlier, some very sophisticated AI control and algorithms to absolutely do this. So if you looked at, for example, let's take care in the home and let's say elderly, doesn't necessarily have to be elderly, could be somebody who's ill. But if you look at that, not only can you detect someone's motion in the way of the direction they're moving, or just moving, you can detect direction of them. You can even detect if they fall over. So this starts to bring on some significant other care facilities and solutions. Now, also, when you look at the traditional motion sensing, you need proper good full motion, the whole body moving through the field of detection to be able to understand that is motion. With Wi-Fi sensing, where it can actually be so sensitive because of the Wi-Fi field, you can even detect potentially breathing. So we all know, for example, an elderly person sitting down at home watching TV is not going to be moving a lot. But if you can still detect their breathing, obviously that's a big advantage. Yeah, so there's all sorts of things like that you can start to do. Mentioned here about tracking, about direction of movement and that sort of thing. Start to recognise activity. So it's not just detecting motion, understanding direction. There's also what they are doing. You can detect what somebody's actually doing. Are they making a cup of tea? All those sort of things. So it gets very, very, very clever, very sophisticated. And the imaging one, I'll explain that a bit further because that's a little bit confusing. What's Wi-Fi sensing got to do with imaging? Well, actually, it's about creating the image of that environment. So with the Wi-Fi sensing, you can not just detect the movements and things like that, but you can actually start to build up an image of an environment, a 3D image of the environment where it gets reflections and bounce on. And this is very similar, for example, in when you look at the way radar works and those sort of things, and especially when you're looking at the robot vacuum cleaners, like I was mentioning earlier, as it maps out an environment where certain objects are in the way and that sort of thing. So it can do a similar sort of thing with Wi-Fi sensing, understand what objects are where, what's been moved, what's been placed somewhere, what shapes they are. So you can start to build up a very big picture. And yeah, one that's a bit of a risky one, but even gesture. Yeah, you can understand gestures because it can be that sensitive to be able to establish whether someone's waving their hand or waving a finger at you. And hopefully they're just waving that finger pointing at you rather than anything else. But it is that sensitive, it is that capable. So the takeaways of Wi-Fi sensing, it's not new, it's just new into the homes. It opens up a whole area of use cases, massive set of use cases that can be used for. The benefits of it being able to go through walls and also the range, if you think if the house is covered by Wi-Fi, and don't forget we're talking about if you extend that Wi-Fi using mesh devices, then your range of motion sensing and detection increases as well. So it works off of the Wi-Fi that's there. There's nothing new in the Wi-Fi to do here. It's existing. It's a part of the chips that are done today have that CSI capability. And it's just interpreting that and using that. You don't have to have multiple Wi-Fi devices around the home as in a router and loads of mesh. Because let's face it, loads of Wi-Fi devices are already in your home. You have your router, yes, that's where you'd be collecting the data from, but you have a lot of Wi-Fi devices. Your Amazon Alexa or your Google, Home or whatever it may be, your Wi-Fi TV, cameras, all these devices have all got Wi-Fi and all help build up that Wi-Fi field, which the CSI can be detected. Yeah, so There's Wi-Fi sensing for you, and I think this is a big one. This is a huge topic. 5G, FWA, I've talked about this, the last mile solution. I want to go a bit further on the futures here for you. I've spoken about the potential before, but there's a little bit more to add to it now and where we're going with it. So we all understand that, you know, fibre is the way forward. Of course it is. We're all trying to go down the fibre deployment, but we all also know, especially in the ISP world, that trying to get fibre to absolutely everywhere is becoming really, really difficult, and in some elements, impossible. And when I say impossible, I'm talking about from a financial viability, because it just costs too much in some areas to get a fibre into somewhere. Yeah, and that may be a single home, it may be multiple homes in a particular environment. And we're starting to, you know, have feedback from some ISPs. On average, you know, the cost they accept to deploy an individual fibre customer is between £1,200 and £1,800 per premises. Yeah. And that is seen as, you know, if you've got a customer in for a certain amount of time, you know, you'll recover that. Yes, of course, there's some element of funding and things like that from government on some of these on voucher schemes, things like that. But that's kind of like the average that's being seen. However, some, from the information we're being fed back, some premises could end up costing sort of 25,000 to just for a single premise. Now that just doesn't cost it. That's just too expensive, and you cannot create a business case against trying to deploy to them. And if you've got a village that you're trying to deploy to where maybe, you know, there's 10, 20 people that are going to cost 25 grand each to try and deploy to because of where they're located in relation to the village, then, you know, that becomes non-viable. So a solution to be able to actually get a high-speed broadband connection to those people, those difficult to reach, is the 5G FWA solution. So we have products. TP-Link have had products for a while on the 5G side where you can do this. Here they all are. You know, I've shown these a few times. You will have seen them, hopefully. But what is always needed to be able to do a solution like this is to actually have a 5G base station. Now, of course, if you're going to go and start putting up a mast, 30-meter mast, and lots of other, you know, equipment down the bottom in a cabinet and all these sort of things, yeah, then it'd be, you know, the cost viability of doing that, you know, you're starting to get into you know, 80, 90, £100,000 to put a tower up, maybe even more. And that just isn't cost effective. Again, it starts to, you know, become non-viable again. However, we are working with a partner, and it's not from TP-Link. If you want introductions, please come and speak to us. We will engage those people. The people who we're working with. They do a 5G base station in a box. Okay, it's about, I guess if you're looking for sizing, it'd be like putting 3 shoe boxes together. Yeah, that's the sort of size it is. So it can go on, and it's externally capable. You can mount it outside as an outdoor unit. You can put a simple pole up by a location where it's needed and mount this on it. You could fix it on the side of a wall of a, you know, centralized property or something like that. And what it provides you for is not a massive base station like you would see from your regular, you know, Vodafone's, 3s, O2s, EEs, those sort of people. Of course, it's not like that. And it only serves, you know, up to 128 users, although it's recommended to don't go above half of that. And that's purely because of your uplink speeds. You know, you've got to think about contention and those sort of things. And adding antennas onto this, traditional antennas onto this, an omnidirectional environment, you're probably looking at a range between 1.5 to 2 kilometers would be your maximum. So this isn't, you know, something that's going to, you know, cover the country. It is specifically aiming at a village type environment where maybe the village itself, the main core of the village, that's all fibred out, but there's some outlying properties around the village that you can't get to via fibre because it just costs too much. Maybe mounting 1 or 2 of these around that village will actually give you that coverage to be able to provide a full coverage across the whole village with a high-speed internet. Okay, so what does that actually look like? Well, here's an environment. We have a village here. Quick snapshot picture taken off of Google Maps, and you've already got, for example, a 5G mast or 4G mast here. So it's not a case of the villages don't want these sort of things in there. They understand nowadays about having a 4G or 5G mast up to give them mobile coverage into that. But of course, that is from the likes of a Vodafone or a 3 or an EE or an O2, and that is purely for their standard mobile coverage. It's not for the ISP to be able to provide a high-speed broadband service. Of course, they might go and try and get broadband from the Vodafones or whatever, but that could be a more significant cost. So what happens, of course, is the ISP comes in and they lay fibre all around the village where they can actually get it to, where it's commercially viable to actually do. And they provide all those homes, just tails off of those. But of course, you end up with these outlying areas where you cannot get a fibre to. It just costs too much money to reach out to there. So what you do is you put the base station in and put the NCPE devices out there, and now you start to get full coverage of the whole environment. And those outlying customers, you can now pull into your network, and all it needs is connecting the fibre from your ISP deployment into that mini base station to be able to do that. So there's a solution. We can see this coming a lot more in the future, and it is a future. Like I say, it's not tomorrow, but there's a lot of deployment that has to go in place, and it's starting to be seen already that there is some difficult to reach customers in every single village, and so this could become quite a big thing. Next subject, TOC, Matter and TAPO. So TOC and Matter. We spoke about Matter earlier. You're very aware of TOC. I hope if you've attended many of my webinars before, TOC always gets in there, and this webinar is no different. So interesting thing that we're looking to do is to actually add the Matter element into TOC. What that means is that Matter products would be able to be managed or controlled or monitored in the TOC environment, and you'll start to see us doing demos of this. We did a very, very basic, simple one in Network X, Mobile World Congress. We will be doing that in Barcelona, which is next year. You'll see demos of this where you've got TOC managing a couple of different devices, a camera, a light, a smart plug, that sort of thing. So you'll see this is obviously something that's got to grow over time and more elements added in and things like that. But what it does mean is that your customer service agents, if you're running the TOC platform, will also, if it's a Matter set of smart home products, would be able to monitor those devices as well for the customer, and maybe set up the if this then that rules, and do things like that, and start adding this as a service offering to your customer base as an ISP, which is another revenue stream. Okay, and essentially these are some of the things you would be able to do by using the Matter environment within TOC. You'd be able to look at alarms, and those alarms may be things like the battery is going flat on a sensor in the smart home environment, so you can actually notify the customer that they need a new battery, or they need to charge up the battery on their doorbell, or on their if we do a Matter doorbell or something like that, or their other sensors. So it can bring up alarms and give you information into the TOC platform, which the customer service agents are actually monitoring. I said set up if this then that rules for the customer, because some customers struggle with that. They may not understand how to do that, or if they've got quite a lot of devices around, they may not understand which one's where and how it's going to work. So it provides a big facility in being able to do things like this, and that brings it all into that into the one platform. Obviously, the customer themselves in our world will still be using the TAPO app to do their things at home themselves. nothing to do with particularly with Matter, although Matter would still be a part of it. But the Matter part coming into TOC enables TOC to be able to control, monitor, onboard, set up, react to alarms, optimize the environment and things like that for the customer, which is that revenue stream for an ISP. So again, this is one that's coming. We are doing this. It's coming you'll see more and more of it happening over the coming year, and more will happen as time goes on. So, last topic you'll be glad to hear, AI and machine learning. Quite a big topic though. A lot of stuff we do on this already. A lot of stuff's going to be coming. This is what I'm going to be talking about in here, this subject at the moment. So I'll step onto it very quickly and go through it for you. TOC, again, wouldn't be a webinar for me if we're not talking about TOC. This is already in TOC. This is stuff you can already do. There's a big AI element within the TOC platform. For example, and I've given a few examples here, if a customer's suffering from poor Wi-Fi coverage, you might get up an alert that comes up and says, like it does here, the customer's been struggling with the RSSI on the client for the last 12 hours. And there's a summary of, what, why and how, why might this be happening? What's causing it? And you get a bit of a chart here showing that they've been having a problem for the last 12 hours. So the AI bit here is actually getting suggestive. It's telling you the symptoms and the root causes, but you can also go into the suggestive solutions. And when you look at those, it'll actually come up and give you ideas, or your customer service agent ideas about, talk to the customer about this. Ask, is it they need to move closer to the nearest AP, or have they not got any APs, as we can see in this map here? Maybe they need an additional mesh unit. So these are all recommendations and suggestions that the CSI agent is actually given on the TOC platform to them, that they can talk to the customer about to help resolve that problem quickly. Similar thing, I won't go in as much detail, but again, a strong Wi-Fi interference. Maybe something's happening. We can see on the graph here, certainly there's interference coming in. And, actually saying up here, in the last 3 hours, there's been a lot of congestion in a particular channel on a particular frequency. And actually comes up and tells you what, why and how, what's going on. That's your symptoms, your recalls. Go on to the suggestion and actually tell you, maybe you want to look at changing the channel. Check out different channels. Do a Wi-Fi test on the channel to see if you can move them to a better channel, and so therefore avoid that interference and get a clearer signal. So all things that suggested, all AI associated. A high association failure rate. Again, information about what's happening and why or what. And this is, in this case, a client keeps dropping off the network. Well, why are they dropping off the network? What's going on? Some information as to what may be causing that problem. And again, this may be out of range of an AP or something like that. And so the suggested solution, various different options here about what you can ask them to do, get the client to do, to try different things, get the customer to move closer with the client, maybe add a device in, and maybe move the device they've already got around. So a lot of AI support and help to the customer service agent, and this already exists within TOC today. This is their facility should be using in the TOC environment. Another part of this, which is becoming more and more important, is the data that we can drive from the TOC platform with AI, and actually listing out data analytics that can be used by the ISP for various different things. Now, in this environment, we've got a lovely environment here. It's nice and clean. The Wi-Fi coverage is good, and there's little Wi-Fi interference. We can see all these sort of things. That's great. Over the period of a month, how it was acting on each day. So it all looks good. And even the internet performance, well, it's great. Here we go. Look, you can see they're using their internet pretty well. It's giving them a speed which is, around the 500 meg downloads and around about the 300 meg uploads on average. Now, that information, that looks good. That's great. That's great information. But that can actually be used by the ISP, by their sales department, or there, as a bit of a push here, you can look at this customer and this data that comes back up from this, and you can collate all this data in bulk. That actually starts to suggest that this customer's using their bandwidth all the time. They're maxing out. Maybe these guys could do with an upgrade to a gig as opposed to a 500 meg. There's a sales opportunity. There's a reason to go and actually speak to that customer. Yeah. Similarly, here's one where the Wi-Fi isn't so good. As you can see, this customer over the month has had a real problem with their Wi-Fi for one reason and another. Investigate into it. Low coverage, by the looks at the coverage level is dire, not good at all. So from that information, yes, there you could be suggesting, the customer service edge, you could be suggesting about moving stuff around, or the clients being closer to the router or the APs that are there. But more so, this is again sales data. Give it to the sales guys and say, go and speak to this customer, and all the customers like it because they are probably good targets to be sold more APs, more mesh units, and improve their mesh coverage network. So all this information again is already in TOC today. Yeah, just needs to be there to be used. So where else do we use AI? We already use AI in our mesh environments today. AI-driven mesh. And what does that actually mean? Well, we're using AI for a lot of things to control various different elements of a mesh environment, and on how it works and the efficiency of it, and identify issues within the mesh environment and move things around, make the mesh better. So let's look at that a little bit further. So here is our traditional Wi-Fi mesh. Our guy here is moving around his environment, and he's being passed from one mesh unit to the other, which is the standard traditional mesh, nothing out of the ordinary there. However, we have our AI-driven mesh capability where we're actually monitoring and running the roaming. What we're doing in an AI format here is we're actually starting to understand what that customer does, that client is doing, when they generally move around. It becomes predictable what they do. If they move from one place, then predict that they're generally going to go to the other place. He's always going to go from one to the other to the next. He never moves from one and sits down and sits in that one place without going on to the next one. So AI in our world is learning this in our deployment, and it starts to predict when customers are moving back, what they do, the applications they're running, and therefore that makes the roaming more efficient, more effective, more predictable. We switch things over faster. We know when it's going to happen, or we start to predict when it's going to happen, and we're able to provide a more efficient, more stable, more effective mesh environment, and using AI to actually do that. Then in our another mesh environment with healing of a mesh network. So yes, the mesh is there, it's all running, everything's fine, it's all been set up, all looks lovely, and then an interference comes in. Okay, in this case we're using a microwave as an example. Somebody starts cooking their lunch or their dinner, and the interference from the microwave actually upsets the link, the original link between these two devices, which is creating the mesh. So in that happening, we'll then heal using AI. We start to look at and monitor and say, is it best to actually go round this other route? Do we stay here? In this case, no, it's better to go round. But when the microwave stops, okay, we can, using AI, we're detecting the environment still, and we'll go back and we'll actually re-establish what was the best environment in the first place, the best setup for the mesh. So again, all of this is being controlled in the AI environment. Another part of it, and again, this is all still stuff we do today, band steering and AP steering. Okay, we use AI in this. Now, band steering, simply switching a client from 5G or 5 gigahertz to 2.4 gigahertz, or vice versa, depending on the congestion in the environment. We're monitoring that and using AI, making intelligent decisions on whether the client should be moved from one frequency to the other. So that's one part. But we also do AP steering. So in a mesh environment, as a client moves from one access point to the other, traditionally, as we've seen in the previous slide, that obviously you're moved from AP to AP, from one device to another to ensure the best signal. Now, it's always possible that moving across from this access point to this access point, ordinarily you would say, well, that's got to be the best solution, because obviously you've got a stronger signal here, so that's going to give you the best performance. Well, that's not necessarily always the case. If it's a busy environment, if there's a lot of clients already sitting on this access point here, and you move across and you haven't got any intelligence, any AI intelligence going on, you're just going to move across and you're moved into a congested, busy access point. And therefore, your performance may not be better, may be worse than if you were standing here but connected to this access point over here. Maybe far better to stay where you are. And in that case, that takes some intelligence there from the AI to understand the environment, understand the client movement, understand the congestion, understand everything that's going on, and ensure that you remain or move the connection to the best possible performance provision intelligently using the AI. Another part of the AI that we do is our AI on quality of service. This is new stuff. This is more and more coming in. This is only just starting to come about. So, bear with us as we put more into this. And essentially what we're doing here on the AI side, obviously on our quality of service, we're using DPI, so deep packet inspection, to understand what the various different data packets are, what the application is within that, and know whether or it should be prioritized or where it should be prioritized. And then, feed that into, the traffic shaping element and the quality serving bandwidth reservation to ensure that you've actually got the best quality of service. And anybody who doesn't understand or know what deep packet inspection is, basically just a very, I believe, a very simple way of explaining it. If you think of your packet, your data packet being a letter, and the quality of service element here is like your postman, and what he's going to do is he's going to look at the address on the envelope to understand where he's going to send that. That would be a standard sort of look at what a data packet is. Whereas deep packet inspection, that would be like the postman getting the letter, reads on the address where it's got to go to, but now he actually opens up the letter and looks at the letter, looks at the information inside, looks at the data to establish what it really is and what it's really doing and what it needs to do and where it needs to go. And so intelligent decisions are then made against that to prioritize that at maybe a better level, maybe for video streaming or voice or whatever it may be, or gaming or something like that. And of course, that is also looking in the AI quality of service database to understand what has been prioritized before, what the prioritization has been used as before for particular applications. And that, of course, is something that grows and develops as more gets used, more apps get in there and used and things like that. So there's that a lot of AI being used to drive this and make sure that it absolutely gives the best performance possible. And in the event of using DPI, yes, but we've also got DFI. For those who don't know DFI, that's deep flow inspection, and that actually is a little bit more of a high level thing. It looks at the standard flow of data. Where is it going to already? Where is it, should we carry on going that route? Should it be used in that environment? And make some intelligent decisions on the quality of service and if that's where it should be and how it should be prioritized, etc., etc. So a lot of clever stuff going on in there using AI. Another one that we're gradually deploying more and more into the products. We're nearly finished on the slides. You've only got one more slide after this one. The AI power saving. So a lot of monitoring. There's a lot of stuff. I referred earlier on Wi-Fi 8 about doing systems that are using less power, and this is becoming more and more important. One thing for obviously the power usage for the home, people don't want to be having things using all power and costing a lot of money, but also from an eco environment as well, the green environment about using less power and energy and these sort of things. So what we're doing here are our AI power saving capabilities is we're looking and monitoring the traffic, the times of day, what traffic types, when things are being used. And again, we start to predict and understand habits of the way people use them. Obviously, the simple one there would be, in the middle of the night, it's unlikely that too much data is going to be transferred over Wi-Fi. So what we can intelligently do there is we power down, lower the power requirement for driving the Wi-Fi, but also then starting to understand through AI prediction at what time the people of the house wake up and start to do stuff. And so instead of waiting for them to start doing data and then trying to bring the Wi-Fi up, instead you'd bring it up just that little bit before it, knowing that that's when the thing's activity starts to happen and start to power it up and bring it up to full power to ensure you're providing the best service possible for the customer. So it's all about understanding the predictions, the traffic, the wireless, the behaviour, excuse me, and all those sort of things, and the bandwidth requirements, and being able to power up, power down, reduce the operational cycles within the CPU, not stop doing so much because you don't need to, and reduce the power they're actually using. And that obviously has, as I was saying, a lot of benefits. One for the home user, not using so much power, but also from the eco and green perspective as well, which is directives that are being placed out there by the various different governing bodies and agencies and governments in EU. Everybody's jumping all over this at the moment, as you'll all be aware, I'm sure. So last slide from an AI perspective, and actually other than the Q&As and another thing that we're going to get you to do shortly, so be ready. We're now moving into the era of AI smart antenna control. So this is getting a bit more sophisticated in the way we use AI to actually ensure that you're getting the best signal possible within your, in this case, 5G signal. So this is deployed on a 5G device, and this is using for the 5G, not for the Wi-Fi in this case, this is on 5G. Now, this device has multiple antennas within it, even though it's only going to use 2x2 or 4x4 type of environment, but it's got a lot more antennas in there than that. Some are omnidirectional, some are directional. What it will do, the AI, it will continually scan the environment to understand which of all the antennas would be the best to be used to get the best signal, not just the highest speed, but also the most stable, most efficient. So a lot of intelligence going into this, because it may be that using a couple of the directionals and a couple of the omnidirectionals may provide the best signal quality and signal power and throughput, rather than just doing all directionals or all omnis or something like that. And not forgetting your multiple antennas within a device are pointing slightly different directions as well, because of the positioning that they're in within the case. And so again, different antennas will receive different signal qualities and signal capabilities. And so AI is being used to be able to improve and make a better signal capture. And so better performance gives you better speed and better coverage. So AI being used in quite a sophisticated way here. And this is all happening automatically without anybody having to interfere or do anything with it. Just simply sits there quite happily monitoring away and doing this for you. So there you go. A lot of AI capabilities. You can see a lot of ways we can do stuff.